Okay, here we go. We're going to talk about side angle side congruence. So if I know the length of the side, so the first thing I did here is I measured this length. So I measured this to be 2 inches, okay? And then I measured this to be 2 inches. So I know that these two sides are the same length because I measured them. Okay, and then if I use my protractor, I can measure the angle. So I put the dot right here at the end of the line, and then make this line up here. And then I measured it to be 40 degrees. So I put a dot right there at 40. Same thing here. I put this open circle here at the end of the line and made sure this lines up here, and I'm going to put a dot here at 40. So then if I draw this line here, then I've got my 40-degree angle. So I know this angle and this angle are the same length, and this line here is the same length as this line here. And now I'm going to, let's make these measurements the same. So how about I'm going to make this 1 inch long, just arbitrarily picking 1 inch. Okay, so if I make that 1 inch and I make this 1 inch, then I can connect my, so I know this pink line right here is 1 inch, and this pink line here is 1 inch. And if I connect that, this 1 inch mark to this 1 inch mark, then I know that I'm going to have congruent triangles always. So no matter what the length of the pink sides and what the length of the blue sides, if I know the angles in between are the same, every time you're gonna you do side angle side, because here we have a side, an angle, and a side. A side, an angle, and a side. We'll always get congruent triangles. Okay. Now, in 2.7, we're going to talk about angle-side angle relationships. So just like before, I measured the length from here to here, which I measured at 2 inches. Okay. And here I wanted this to be the same, so I measured that to be 2 inches. Okay. And then, like before, I measured the angle, and on this first angle, so I put the open circle here at the end of the line, and I measured it 25 degrees. So if I go over here halfway between 30 and 20, I have a 25-degree angle, and then so right there, it's a 25-degree angle. And I don't know how far I'm going to go, so I'm just going to draw a line that's really long. Okay, and then I do the same thing. I put the open circle there, and I line it up and make another 25-degree angle, put this dot there, connect this up, and I've got my 25-degree angle. Now I decided just arbitrarily, I picked 50 degrees, so I put the open circle at the other end, lined this up, and then I made a mark at 50. Some of you are thinking 130, not 50. No. If it was an obtuse angle, it'd be 130, but because I'm going acute, I'm going to do 50 there. Okay? And same thing here. I put this at the end, and I mark it at 50. At 50, so then I connect that end to there. And so whenever this angle is the same as this, and this angle is the same as that, and if I know that this line is the same length as this line, then when I connect these together, so if I connect this to here, and this to here, then I know that these triangles will always be together by the relationship of side or angle side angle. Okay? So anytime that you know the length of a side is congruent and then the angles on both ends are congruent, then you know those triangles will be congruent by angle side angle. Okay. Now, in the notes they talked about what do you know about parallelograms. So I've got this ruler and I know both edges of the ruler are parallel. So I drew a line here and here. Okay, and then I moved my ruler again and I drew a line here and here. Okay, so I've got my parallel lines. Okay, and then where those parallel lines intersected, I connected the dots. Okay, so there we go. And then I labeled the points. I labeled this A, B, C, and D. Okay, now I know that if I want to know, is triangle ADC congruent to triangle ABC? So this triangle congruent to this one. Is it congruent? Well, I know that because these two triangles share the same side, I know that AC is used on both triangles. So since AC is used on both triangles, you could say the same side is used on both triangles, and that is called the reflexive property. Okay, but if you just know that the same side is used on both triangles, that should be good enough. Now, another thing to note is that, okay, so these are parallel lines, right? So if these are parallel lines, you know that this angle here has got to be congruent to that angle there. Now, why would this angle here be congruent to this angle here? Well, if I've got my parallel lines, I know that these yellow ones are alternate interior angles. So angle BAC is congruent to DCA because they are alternate interior angles. Now, the same thing, if I look at my parallel lines this way, I know that angle DAC and BCA, that those angles are congruent also. Because if these lines here are parallel, then this angle here, the blue one here, I'm putting an arch with 2 marks. Here I'm putting an arch with 2 marks. I know that these are alternate interior angles also. So I can say DAC is congruent to BCA because of alternate interior angles. So, so now I can say that these triangles are congruent because of angle side angle. Angle side angle. Okay. Now we go to 2.8, perpendicular bisector congruence. So I just drew a line. It doesn't matter how long you draw it. Just draw any old line. Okay. Then I got my compass and I drew 2 circles that were of equal diameter. Okay. So 2 circles of equal diameter. So I just pick a point. Any point, okay, well, where the 2 circles meet, I have to draw a point, and then I'm going to draw a line connecting those 2 points. Okay, so this red line here is the perpendicular bisector. We know that that's 90 degrees and that's 90 degrees. Okay. We also know that the length, this length here and this length here is congruent, right? And we know that this angle here and this angle here, those are congruent. this angle here and that angle there is congruent. And if I connect this point here, the black point and the orange point, if I connect those there, we know that this side is the same for both lines, right? So now I know that this triangle, let's just put some letters here. So let's call this A, B, C, D. So now I can say triangle A, B, D is congruent to triangle C, B, D. And because it's side, angle, side. Okay. Now, I could put a dot anywhere on the line. I could put one way up here. Let's call that E. Okay. And if I had a dot way up there and I drew a line, there's still going to be congruent triangles. Because if I know that E to B is the same length, I could say that EAB is congruent to ECB. The blue triangles will also be congruent. So EBA is congruent to EBC. And that's also by side, angle, side. Okay, and one more thing before we finish up is I'm going to show congruence by side, side, side. So let's pretend I've got three sides that are the same. This one should be really obvious. Okay, so I got three little sticks. You could use toothpicks. I used a twist tie that I made really straight. And let's pretend that I've got this little line right here. And I'm just going to use a highlighter and do it the length of that. Okay. And then I'm going to take it away and use another highlighter. Any length, any angle will do. Oh, actually, I need to put them together, don't I? Because I don't know. There we go. So I need to have both ends at the end of the yellow line, and then have these connect like up here. It's hard to do. Okay. And then I'm going to use, okay. And then I connect this one, I'll use orange. Okay, and then if I do the same thing, let's use the big line first. Okay, it has to be orange. Okay, so so just like the other one, I need to put these two together first before I do anything. And let's connect them. So the yellow one is the short one. And then the blue one is this one here. So no matter what I do, these triangles will be the same by side, side, side congruence. So if you know the three sides of one triangle are congruent to three sides of another triangle, then both triangles will be congruent. And that is called side, side, side congruence. And sometimes it's represented by three S's. All right, thank you.